The next special case I want to talk about is something called a perfect square. Now, a perfect square, sometimes you're going to use the old method and you'll realize it after you do it. And other times you're going to look at it and you're going to say, wait a minute, that looks ugly, and you'll hopefully recognize that it's a perfect square. What do I mean by this? Well, let's look at the first problem that we have to factor. I've got x squared minus 6x plus 9. Now, you probably look at that and you say, oh, that's pretty straightforward. That's just a regular old trinomial. I got x and x, and I've got positive 9. I need factors of 9 that add up to be negative 6. And hopefully you'll eventually come up with the pair of negative 3 times negative 3. Because negative 3 times negative 3 multiplies to be 9. And when you add it, it adds to be negative 6. So you write minus 3 minus 3. If you get two binomials that are identical, this was a perfect square. You actually need to do a little rewrite and put it together. Some of you are going, huh? Hey, anything times itself can be written as an exponent. 7 times 7, you could write as 7 to the second. I'm writing x minus 3 times x minus 3 as x minus 3 quantity squared. Now, look hard at this. X squared. Can you take the square root of x squared? Yes, you can. 9. Can you take the square root of 9? Yes, you can. Just like on the difference of two squares, you can take the square root of the first and the last number. Now, 9x squared plus 24x plus 16. When you look at this for factoring, you know, if you were to go through, you'd say, oh, wait a minute, a is greater than 1. The first thing we do, common factoring. Can I pull any common factoring out of that? No, they don't have anything in common. I hope it jumps out that you could take the square root of the first and the last. If you can, go on ahead and try and see if it's a perfect square. So 3x and 3x, and the square root of 16 is 4 and 4. Now, if you look at your middle term, to get positive 16, the only way to get a positive is a positive times a positive, isn't it? Or a negative times a negative. If we were to put minus signs in there, it would be 3x times 3x, give me my 9x squared, and my 3x times negative 4. That would be negative 12x. And then it would be negative 4 times 3x. It would be another negative 12x. If you put minus signs in there, it's going to make the middle term negative. If you put plus signs in there, it's going to make the middle term positive. Now, let's multiply this out. 3x times 3x, 9x to the second. 3x times 4, 12x. 4 times 3x, 12x. 4 times 4, 16. Now, I didn't write it down, but we had a 12x and a 12x, didn't we? 12x and 12x, 24x, it's a match. That's how you factor that. Now let's look at the last one. Oh, 25 times 64, and these are very contrived, guys. If you see their huge numbers like this, there's a very good chance it's a perfect square. You can take the square root of 25x to the second. It's 5x. You can take the square root of 64y to the second. It's 8y. Okay? Now again, these are both positive, aren't they? If the middle term is positive, we write a plus in there. If that middle term is negative, we end up writing a minus. I could multiply it out. 25x squared plus 40xy plus another 40xy plus 64y squared. You put together the middle terms. Does it give me 80xy? Yes, it does. This is the right answer. When you are doing these, if it looks like it's going to be huge and ugly, well, I say this is the right answer. I have to take a step back. It's the right answer as far as we go. 5x plus 8y, quantity squared, because it's something times itself. On the top one, 3x plus 4, quantity squared, because it's something times itself. It's easy to forget to simplify that step further. I actually forgot on this one and almost forgot on this one. But you do have to go one more step and write it as a little 2. Keep in mind that as you're doing these, the large numbers, give it a shot. It'll probably work. Now, as a little quick side note, sometimes people say, Mr. Trapp, I don't want to take the time to multiply these out. There is a quick way to see if it works. This is just a little trick. 8 and 5, or 5 and 8. What's 5 times 8? 40. You take whatever these two terms are, multiply them, and then multiply it times 2. Because if you look, you had two 40s there, didn't you? So you got to multiply times 2. 5 times 8 is 40, times 2 is 80. All right? Well, go on ahead, take a shot at these in your homework, and good luck.